Welcome back to another video of Engineers Academy. And guys, over here in this video we are going to talk about the zeroth law of thermodynamics. So guys, in our previous video we have seen the heat and the specific heat of the objects, how the heat flows from hot body to cold body. So that is the basically nature of the heat. So that's we have seen in our previous video. So guys, now over here in this video we are going to discuss the laws of thermodynamics, that is zeroth law of thermodynamics. So guys, please watch my video till the end, and guys, if you are new to my educational channel, please do subscribe to my educational channel Engineers Academy. So, and guys, please press the bell icon also. Whenever I upload a latest video, you will get instant notification. Please press the bell icon also. So guys, without wasting any time, let's begin with our today's topic, that is of zeroth law of thermodynamics. So guys, whenever heat flows from hot body to cold body, consider, let's say I'm having a glass of water. The temperature of water is around 100 degrees Celsius, and suppose I put a solid body, let's say a steel ball. I'm having a steel ball, and I just drop that particular steel ball into water, into that hot water. The heat flows from the water molecules to that particular steel balls, and after some period of time, okay, the temperature of the water and the temperature of the steel ball, it remains it will be equal after some period of time. So guys, at that particular point there will be no heat transfer between that steel ball and the water molecules. So guys, at that particular stage we can call it as this particular steel ball and the water, it is in the state of thermal equilibrium. So this particular state at which there will be no heat transfer between two solid bodies, or we can call it as between two systems. So at that particular point we can call it as, at that particular state we can call it as, these two bodies are in the state of thermal equilibrium. So guys, suppose I'm having another body which is also at the same temperature. Let's say I'm having a piece of wood. Okay, so this is also at the same temperature as that of the first body, water, the second body, steel ball. So this will be also having the same temperature. It means if I place that piece of wood into water, there will be also no heat transfer between the wood and your water molecules. So guys, over here we can conclude that if the two bodies are in thermal equilibrium, if the first body is into the thermal equilibrium with third body, then the second body is also in the thermal equilibrium with third body. It means over here the piece of wood and the steel ball, these two bodies are also in thermal equilibrium. There will be no heat transfer between this second and the third body. So guys, this is nothing but the zeroth law of thermodynamics. So guys, why this is called as a zeroth law of thermodynamics? So before inventing the first law of thermodynamics, scientists have to name this particular law of equilibrium, which is called as a zeroth law of thermodynamics. So this is the main reason. If the two bodies are in thermal equilibrium, and if the first body is in thermal equilibrium with third body, then the second body is also in the thermal equilibrium with third body. It means all the three bodies are at the same temperature and there will be no heat transfer across the boundary and across the system. So guys, this is the simple and very easy to understand, that is the zeroth law of thermodynamics. So guys, in our next video we'll be seeing this first law of thermodynamics. So guys, I hope you understood this simple law of thermodynamics. So guys, thank you for watching my educational video. Please do subscribe to my educational channel Engineers Academy.